laid out before me the basic properties of logarithms and the rules of logarithms and the rules of exponents. But first let me go over briefly the basic properties of exponents. I wasn't really sure where I should include these. It didn't really make much sense to start talking about them when we were just trying to learn how to use the notation first. But anyways, here are a couple basic properties. The first one is log base a of a is equal to 1. What this is basically saying is what power of a gives a. So a to what power is equal to a? The only power is 1. A to the first is equal to a. So that's just a basic property of exponents. So that's what these first two are going to be. Just basic properties of exponents rewritten in logarithmic notation. So this second one is log base a of 1 is equal to 0. So log of base a. So what power of a gives 1? The only power that is going to give 1 is 0. That's the only, for any base a, that is the only one, because we don't include 1. Otherwise, we could say 1 to the first is equal to 1. Or 1 to any power is equal to 1. But we don't include 1 as a base. So therefore, since we do not include 1 as a base, the only exponent that can possibly give us 1 of any base a is 0. So that's a basic property of logs. And these last two don't really have anything to do with exponents. What they are is basically telling us that we're doing a function of an inverse function, or an inverse function of a function. So let me explain what I'm talking about. Log base a of a to the x is equal to x. So what this is basically saying is that if we take the log base a of a base a to the x, it's just going to give us back x. And the reason for that is a to the x is a function, and then the log of a is the inverse function. So what we're doing here is we're taking the function of it, of some value x, and then taking the inverse value of that. So basically, we're doing something to it and then doing the exact opposite to it. So it's like moving it up 10 feet and then pulling it back down 10 feet. Actually, here's a pretty simple example that people should be familiar with. So it would be as if we took the function x squared and then took its inverse, the square root. No matter what you put in as x, you're always going to get back the same value. Because this function undoes whatever this function just did. That's the whole point of an inverse. And similarly, if we have a raised to the log base a of x, it's almost the same thing, except in this place, we're first doing the inverse of it and then taking the function of it. So we're doing the inverse function first of x, and then taking the function of it. And that's also going to be equal to x. We're undoing what the other function just did. Now this would be similar to taking the square root of x and then squaring it. It's the same thing, it's just backwards. So that's what that is. Now let's talk about the rules of logarithms. The rules of logarithms are basically the rules of exponents written in logarithmic notation. So first let me talk about the rules of exponents, since we're already familiar with those. If I have identical bases, a raised to the v times a raised to the u, it's the same thing as a raised to the v plus u. And that's kind of what this is saying. This is saying if I have a log base a of m times n, I can write that as a sum. And that's what this is saying. If we have the same base and we're multiplying together, we can write it as a sum of the exponents. Here is a similar thing. If we have division, base a divided, base a of v raised to the v and base a raised to the u, it's the same thing as the difference between v and u. And that's what this is also saying, is if we have an m and an n, and they're being divided, a log base a, same base, then it's the same thing as subtraction. And the same thing with the power rule. So what I'm going to do is very briefly explain where these come from, and hopefully it will be easier to understand. And then I'll do one example, and then I'll make another video doing a whole bunch of problems. So let's figure out where these come from. So what I'm going to do first is make up a couple of functions. First, I'm going to say that a raised to the v is equal to some number m, and that a raised to the u is equal to some number n. Now I need to start with my rule. Or actually, let me quickly write what these would be in logarithmic notation, because that's going to be used later. So let's just do that now. So if I want to take the log of this, so log base a of m is equal to v. What power of a is equal to m? That is v. A raised to the v is equal to m. And for this one, log base a of n is equal to u. In order, what power of a is equal to n? U. So now let me start with, let me just do the top one. We'll start with this. So we know this rule of exponents. A raised to the v times a raised to u is equal to a raised to the v plus u is equal to the sum of the powers. Now what I'm going to do is say that a to the v is equal to, well, actually, here, let's do this first. Actually, this is a better way of explaining it. A to the v times a to the u is going to be equal to m times n, right? A to the v is equal to m. A to the u is equal to n. If we multiply these together, they're equal to m times n. Now, next what I'm going to do is, let me first use this. So we say that a times v, a raised to the v times a raised to the u is equal to a to the v plus u is equal to m times n. Now what I'm going to do is take the log of both sides. So log base a of a raised to the v plus u is equal to the log base a of m times n. Now, as we discussed earlier about the basic properties of logarithms, taking the log base a of a base a is taking the inverse of a function, and what it's just going to leave us is the x. So log base a of a raised to the v plus u is equal to just v plus u. And this is equal to log base a of m times n. Now the final step is to replace v and u. V is equal to log of a times m. When we converted the original equation into logarithmic notation, and u is equal to the log base a of n. So I can rewrite this entire thing as log base a of m. I just replace this v with this, plus log base a of n. I just replace this u with this. And this is equal to log base a of m times n. And if I scroll up, I can see that I started with this, and I managed to convert it to logarithmic notation, and it is indeed equal to this. So that wasn't that bad. It's just rearranging the equation in the form of logs. And the division one, or the subtraction, is almost completely identical. It's the same process. So I mean, whatever, I guess I'll do it. Let's cut this out. Whatever, I'll do it. I've already come this far. Whatever. Anyways, so let's do the next one. So the next exponential rule that I want to convert into logarithmic rules is a raised to the v divided by a raised to the u is equal to a raised to the v minus u. A raised to the v divided by a raised to the u, and this is equal to a raised to the v minus u. So the first thing I want to say to myself is that a to the v and a to the u can be replaced. A to the v is equal to m. A to the u is equal to n. And this is equal to a to the v minus u. Now what I'm going to do is take the log of both sides. And this should start looking familiar. So log base a of m over n is equal to log base a of a to the v minus u. These cancel out, they undo each other, they're inverses of each other. So log base a of m over n is equal to v minus u. And now I do the same thing I did last time. I go over here and say v is equal to log base a of m, and u is equal to log base a of n. So this can be written as log base a of m divided by n is equal to log base a of m minus log base a of n. Now if I scroll up and check, this checks out like the first one, and now all I have left is this power rule. And it doesn't really take up that much space, I don't think. It was a to the v raised to the r is equal to a to the v times r. Now the first thing I'm going to do is say a to the v is equal to m. So m raised to the r is equal to a to the v times r. I don't have to replace both if I don't want to. It's the same thing. I can replace one if I want to. Oops. Didn't mean to do that. So now that I've replaced one of my AVs, my AV on the left, with m, what I'm going to do is take the log of both sides. So log base a of m to the r is equal to log base a of a raised to the vr. These are inverses of each other. It just leaves us with our original x, our x being v times r. So log base a of m raised to the r is equal to vr. And again, going back up here and saying that v is equal to log base a of m. So I have log base a m raised to the r is equal to v times r, and I'm just going to write the r on the front because it's easier to see, log base a of m. Ew. And I go back up here and check. That's what I got. So that's where these come from. It's just rearranging of the exponential rules. And that should really reinforce that these should be completely interchangeable, logarithms and exponents. If we write it in one form, it's the same thing, just written differently. So now that we've done that, I'm going to do one problem. And what it's going to involve is expanding a logarithm. What I'm going to do is have, well, let me just write it out. So log base 2 of, what did I do? Oh yeah, x squared times x minus 1 cubed over 2x plus whatever, 5. And what I want to do is expand this logarithm. I want to write this out as not one logarithm, but a sum of several logarithms. And that's going to be one type of problem we're going to be dealing with. And another one we're going to be dealing with is where we have a bunch of logs and I want to write it down, I want to condense it down into one. And these are going to have various uses. There's going to be plenty of times you're going to want to expand them out, and there's plenty of times you're going to want to contract them. And in calculus and in other areas of math, it's very important. So let me begin. And we can begin this several different ways, I guess, but the easiest way, in my opinion, is to get rid of this division. And I can go back up here. You know what, I'm just going to copy this and cut it down. So we just holes all over the place. Alright, well that's much better. So the first thing I'm going to want to do is use this property right here. I could say that this is equal to m and this is equal to n, and I can write this as two different logs subtracting each other. So I'm going to write this as log base 2 of x squared times x. It's not really necessary to write that parentheses out there. I just write it out there just so I don't get confused. X minus 1 cubed minus log base 2 of 2x plus 5. So now I've done that. Now I can look around and see if there's anything else I can do to simplify this more. And there is, because I have two different things multiplying each other. I have an x squared multiplying an x minus 1 cubed. So I can take that as an m times n and say that these are a sum. Write these out as a sum of logs. So I can say that log base 2 of x squared plus log base 2 of x minus 1 cubed minus log base 2 of x of 2x plus 5. Now I look around and see if there's anything else I can do. I've simplified all the division, all of the multiplication. Now all that's left are the powers. Here I have a second power, here I have a third power. And what I can do is bring these down in front of the logarithm so it's multiplying it. Let me do that. That's the wrong red. It's very slightly different. So what I can say is that this is 2 times the log base 2 of x. Because this exponent is now gone, I've brought it down in front of the logarithmic expression. Plus 3 times log base 2 of x minus 1 minus log, it's an ugly log, it's a rotten log, log base 2 of 2x plus 5. And this is as simplified as it can get. There are no more multiplications or powers or divisions to simplify the logs anymore. This expression cannot be broken down, this can't be broken down, and this is as simple as it can get. So this is the final answer. And there are going to be other kinds of equations where we're going to be presented with something like this and asked to simplify it, put it into as few logs as possible, bundle the logs together. So that's that. I'll do another video where I bundle some logs together and chop some logs up, and it'll be fun.